Hello, now we're going to look at a linear regression t-test. So what this is we're doing a significance test to check to see if there's a positive relationship or a negative relationship between two variables, or if it just happens just by chance. To do that, we're going to test a hypothesis of no relationship. The common hypothesis about slope is that the slope is 0, and that's the true slope of all the possible values. Now to do that, we find our t by taking our slope, which is b, over the standard error for slope. So if we have these values, it's very easy. If we just have the other values, it's a little bit more difficult. We'll talk about that. In terms of a random variable, now this is a big deal. Our degree of freedom is n minus 2. df is n minus 2 rather than n minus 1. There's some technical details on why it is that way, but for right now, I think we can just be comfortable that the degree of freedom is n minus 2. And we could also use this for a test for correlation and slope. They're the same test. Now, when we're doing conditions for a regression test, they're much different than the other ones. First, we want to make sure that the responses for y are independent of each other. This is what we just assume. And this one, if we just want to make sure there's not one x value that gets two or more values for y. We want to just assume each point is independent. So that's just pretty much what we write each time. Then we want to check to see that the mean relationship, mu of y, has a straight relationship with x. So we're going to check this equation. So in order to do that, what we do is we check the residual plot for linearity. So if our residual plot is scattered, things are going well. We also want to check to see if our standard deviation is the same for all values of x. That sigma is unknown, but we want to just check to see. And again, we just look at the residual plot that we made for our second assumption or condition, and just make sure there's no fans. Fans means that there's standard deviations low in the beginning, and then increases at the end, or the other way around. We want the standard deviation to be relatively consistent throughout. Finally, for any fixed value of x, the response y varies accordingly to a normal distribution. Now in this one, we look at the residuals, and we make some plot, whether it's a stem plot, box plot, or histogram. Typically, I like to just do a box plot and check for skewness or outliers of the residuals. So those are our conditions. We'll go through an example next.